Hello students, how are you all? I hope you all are doing good. Yes, so we are back again with the next lecture of the chapter, Some Natural Phenomenon. Okay, so in the last lecture, what we have discussed, we have already discussed about charges, some basic properties, or I can say important properties of charges. And then we see what are the methods of charging, or I can say what are the methods of producing charges on any body that we have already learned in the previous class. And we have also learned how to detect the charges by an instrument which is known as electroscope. Okay, so that's all we have discussed in the last class. Okay, so today we are in this lecture, what we are observing, we are basically observing two basic natural phenomena. Two natural phenomena, you already have heard about that. Yeah, so one will be the lightning, or you can say the thunderstorm. Yeah, you can say thunderstorm, or the second thing is earthquake. So all of you are aware about earthquake. Yeah? These earthquake and lightning are pretty much very familiar natural phenomena which we observe in our day-to-day life. Yeah, not frequently, but yeah, at some point of time you all have observed that. Yeah, mostly lightning all of you have observed, but I can't comment on earthquake. Yeah, earthquake is also a very common natural phenomenon. Okay, the basic things about lightning and earthquake is that they produce a lot of loss of life and property. Yeah, they produce a loss of lot of life and property. Okay, so that's why they are very dangerous. That's why they are very dangerous. So in this class we are basically discussing some basic things about lightning, earthquake, how they happens, yeah, how these processes are happening or phenomena are happening, and how to take precautionary measures, to reduce the loss of life and property. Okay, so see what we are going to today learn are these topics. Okay, the theme is clear. Okay, so this is some natural phenomena part 2. So in this lecture what we are going to learn today, these much topics. First will be Coulomb's law, a law related to charges, or I can say the force acting between charges. The second thing is electric field. Third point is the natural phenomenon lightning. Safety precautions. What are the safety precautions you have to take in order to reduce the loss of life and property? Then we will see earthquake, how earthquake happens, some basic things about earthquake, and then we'll see safety precautions during earthquake. Okay, so that's how the lecture flow will be happening. Okay, so what you can see here in this diagram, in this right diagram, what you can see, there is a bundle of charges present at the center, and around this bundle, what is happening, some charges are flowing. Around this bundle, some charges are flowing. If you can see this charge is rotating, or I can say is making a revolution around this bundle of charge. This blue charge is also making a revolution around this bundle of charge. Okay, and this green one is also making a revolution around this bundle of charge. Okay, so something is holding them. Something is holding them, or I can say something is compelling them, or some kind of force is compelling them to rotate around that bundle of charge. Okay, in this second picture also you can see there is some positive charge. Yeah, and around this positive charge there are some negative charges, blue color revolving around it. Yeah, blue charges or negative charges are revolving around the positive charge. So there is some force, I can say there is some invisible force which is making them to revolve around the positive charge, or I can say that is attracting them. And we have already learned in the last class that positive and negative charges attracts each other. So that is that force which is known as electrostatic force. That is that force which is known as electrostatic force. And what about the magnitude of force? That how much force is actually applying? The force can be attraction in the case of unlike charges, or the force can be repulsion also in the case of like charges, either positive or negative. Both can be possible. Yeah, so basically what does this Coulomb's law will give you? Coulomb's law will give you the magnitude of the electrostatic force. What? Magnitude of the electrostatic force which is acting between unlike charges or like charges. Yeah, it can be attractive, it can be repulsive, that is another thing, but basically it will give you the magnitude of that electrostatic force. So what does Coulomb's law say? Coulomb's law say the magnitude of electrostatic force, yeah, electrostatic force, either repulsion or attraction, between 2 point charges Q1 and Q2. So they are supposed two charges of magnitude Q1 and Q2. The force between them is directly proportional to the product of the magnitude of charges. Okay, directly proportional. Mark it, directly proportional to the product of magnitude of charges, magnitude, and inversely proportional to the square of the distance between them, and inversely proportional to the square of the distance between them. That is what the magnitude of electrostatic force is given by the Coulomb's law. Yeah, and you already know the electrostatic force can be attractive or can be repulsive. That you can decide easily. That you can decide easily when you see this picture also. Yeah, see the picture on the right side. If these Q1, Q2 charges are positive, see now they are positive. See, they are repelling by F and F. They are negative, they are again repelling by F and F. And when they are positive, negative, or vice versa, this is the case of repulsion. Now see, negative, positive, or positive, negative. In both the cases, they are getting attracted towards each other. Yeah, that thing you already know very well, that like charges repel each other, unlike charges will attract each other. But by how much amount? That amount is given by Coulomb's law. That the force is given by this expression, which you can see that electrostatic force between 2-point charges Q1, Q2 is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So if you remove the proportionality sign, you have to place a constant. This K is that constant. If you have to remove the proportionality sign, you have to make a constant. So that constant is K, which is Coulomb's force constant, whose value is given by 9 into 10 to the power 9 Newton meter square per Coulomb square. So that is the value of that constant. So I think you are now easily able to identify or find the magnitude of force between any two charges having magnitude Q1, Q2, and the separation between them is small r. So the formula of magnitude is given by F equals to K Q1, Q2 by R square, where K is a Coulomb's force constant given by 9 into 10 to the power 9 Newton meter square per Coulomb square. So that is basically Coulomb's law. And the sign, if I say that attraction or repulsion, which you can observe is from the sign of charges. One thing about Coulomb's law is always remember that suppose you are given two charges, suppose these are positive, positive. So always join their center to center line. So the line joining their centers, the electrostatic force will always act along that line only. So what can I say? Electrostatic force always act along the line joining the charges. Always act along the line joining the charges. So if these are positive, this Q2 charge and Q1 charge is there. So this Q1 charge will repel Q2 charge in this direction by some force F1. And this Q2 charge will repel this Q1 charge with some force F2. Why they are repelling? Because they are like charges. Okay. So this force F1 and F2 are equal basically. These forces F1 and F2 are equal, and both of the magnitude is given by this K Q1 Q2 by R square. So always remember, both the charges are applying equal and opposite force on each other. It can be attractive, it can be repulsive depending on the nature of charges, and their magnitude will be equal. That is given by K Q1 Q2 by R square. Done. So I hope Coulomb's law is clear, pretty much clear. Okay, thumbs up guys. Okay, now we'll move on to the next topic, electric field. We'll move on to the next topic, electric field. So what is the basic meaning of electric field? If I say I'm bringing a positive charge, this is a negative charge. Okay, this negative charge is somewhat fixed. This negative charge is somewhat fixed, and you are bringing this positive charge. Yeah, you are bringing this positive charge towards this negative charge. So what will happen? This positive charge will get attracted towards the negative charge. Yes or no? This positive charge is getting attracted towards the negative charge. Or what else can we do? We can take a positive charge. Now if I bring a positive charge towards this positive charge, so this will repel. Yeah, this positive charge will repel this positive charge. Yes or no? So there is something invisible. There is something invisible which is available around this positive charge. Yeah, there is some region, invisible region around this stationary or fixed positive charge. In what can we say? There is some invisible region in which if I bring any other charge, then that charge will experience a force. Either it can be attractive, it can be repulsive. So what is the saying? That if a charge is present or if a charge is fixed at some point, then there is some invisible region around that charge. In that region, if you bring any other charge, then that charge will experience force. Then the charge will experience electrostatic force of attraction or repulsion. That is another thing. So that invisible area is the electric field. That invisible is the electric field. Okay. So electric field is that invisible area, yeah, or invisible region around any charge, in which if any other charge is taken, it will experience electrostatic force. Okay, that is the thing of electric field. Now mathematically, how electric field is defined? Mathematically, electric field is defined as the electric force per unit charge. Electric force per unit charge. So what we have learned already, that what was the force? K Q1 Q2 by R square. Now force acting on any charge per unit charge means divide by Q. That will be electric field. Electric field is shown by capital E. So electric field is electrostatic force per unit charge. That is the value given by electric field. Okay. And that what about direction of electric field? Direction of electric field is always taken from the direction of force it would exert on a positive test charge. Okay. So what is the case? That the direction of electric field is from positive to negative. That is the thing. This is the direction of electric field. Direction of electric field is from positive to negative charge. Positive to negative charge. That thing you have to remember, positive to negative. Okay. So what can I say? If there is some point charge present positive and there is some point charge present negative. So for point charge positive, electric field lines will emerge radially outward because electric field starts from positive. That's why it is starting from positive charge. And what about negative charge? It finishes or terminates at negative charge. It finishes or terminates at the negative charge. So it will be radially inward. It will be radially outward for positive charge and it will be radially inward for a negative charge because the direction of electric field is positive to negative. And what are these lines? These lines are known as electric field lines. These lines are known as electric field lines. So what are electric field lines? What can I explain? That these lines are used to make a sketch of the electric field. To make a sketch of the electric field. To make a sketch of electric field. That is the thing. That electric field lines are used, or I can say the pictorial representation, because electric field is invisible. Yes, electric field is invisible. So the pictorial representation of electric field is given by something known as electric field lines. And we already know electric field lines will start from positive and terminate towards negative charge. Why? Because the direction of electric field, which is given by electric field lines, is from positive to negative. So that's why electric field lines will always originate from positive and terminates at negative charge. That is the thing. Okay, now you can see here. This is the pictorial representation of electric field lines. This is from positive to negative. This is from positive to negative. This is the original picture. This is the original view. This one is the original view. Yeah. And in this pictorial representation, see negative charge radially inward. Yes. Clear? You can see positive to negative, positive to negative. Okay. So this is the case that electric field is defined as the electric force per unit charge. Yeah. And the direction of electric field is taken from the positive to negative charge. That is meaning that electric field is radially outward for a positive charge and electric field is radially inward for a negative charge. Okay. And electric field lines are the pictorial representation of the electric field. So I think that discussion is clear. Okay. So we will move forward now. Now see, this is the first basic phenomenon or natural phenomenon we are going to see is the lightning. So all of you have seen the lightning in day-to-day life. Yeah. Whenever there is any thunderstorm, whenever there is any thunderstorm or any cyclone, then that are followed by a process which is known as lightning. So there is a saying which is prevalent for the process of lightning is that we have already seen the process of rubbing. Yeah, we have already seen the process of charging by rubbing. So what happens basically during thunderstorm, it is said that during thunderstorm, yeah, during thunderstorm, it is said that air currents move upward and water droplets move downward. Yeah, it is the saying that during thunderstorm, air currents move upward and water droplets move downward. So there is a rubbing between air currents and water droplets. There is a rubbing between air currents and water droplets, and there are some kinds of clouds formed. There are some kinds of clouds formed. So these are clouds. This is the ground. These are clouds. This is the ground. This is ground. This is cloud. Okay. So what is the saying that in the upper layer or in the upper portion of the cloud, there is some accumulation of positive charge due to rubbing, and on the lower edge of the cloud there is some accumulation of negative charge due to rubbing, because we have seen due to rubbing equal and opposite charges will induce or produce on the two bodies. Okay, so due to rubbing there is some positive charge on the upper edge and negative charge on the lower edge, and there is some positive charge accumulated on the ground also. There is some positive charge accumulated on the ground. So what happens when this negative charge becomes so high, when this negative charge on the cloud becomes so high, then this is the air present between ground and air. Yeah, this is the air which is present between cloud and ground. So what happens? Usually air is a poor conductor of electricity. Usually air is a poor conductor of electricity, but when this negative charge is become very high magnitude, yeah, when this negative charge is becoming of very high magnitude and this positive charge is also very high magnitude, then they kind of meet each other. Yeah, they kind of meet each other to become neutral. Yes or no? Positive and negative will meet to form a neutral case. So whenever the charge flows from cloud to the ground, whenever charge flows from ground to the from cloud to the ground, there is some sudden sparks. There is some sudden sparks. You can see these sudden sparks are nothing but lightning. These sudden sparks are nothing but lightning. So basically, this is the process of lightning. That rubbing process takes place. Due to rubbing, upper edge has got the positive charge of the cloud and lower edge of the cloud has got negative charge, and that negative charge will flow to the positive charge of the ground. So due to that flow of charges through the air, there is some current observed, some sudden current or sudden sparks are observed, which are known as lightning, that you can see in this picture. See, there are sudden sparks flowing from ground to, flowing from cloud to the ground. So these are known as lightning. And this process of transfer of charge is also known as electric discharge. This is also known as electric discharge. Okay, so that is the process of lightning. Now I see the basic concept of lightning is clear. How is lightning process taking place? And I can say the amount or magnitude of charges are so high that the current which is flowing, that the current or energy which is flowing from negative to positive charge is so high that it produces a loss of the life and property, that it produces a damage of life as well as property. So that is the case of lightning. So what is written here? Lightning is a naturally occurring electrostatic discharge. Yeah, it is a naturally occurring process. Yeah, natural occurring. Why? Because there is some natural rubbing between clouds and air, yeah, or water droplets. So lightning is a naturally occurring electrostatic discharge during which two electrically charged regions in the atmosphere, yeah, electrically charged regions in the atmosphere or ground temporarily equalize themselves. Equalize means becoming neutral. Positive and negative will attract each other to become neutral. Yeah, causing the instantaneous release of as much as 1 gigajoule of energy. So that much high amount of energy is released. Yeah, 1 gigajoule is a very, very, very high amount of energy that is released during lightning. So electric discharge, that is the process of mixing of positive and negative charges. This electric discharge can take place between two clouds. Yes or no? Whenever this electric discharge is taking place between two clouds, then you can see lightning on the sky itself. It will not come on the ground. But when this electric discharge is taking place between cloud and the ground, then you will observe lightning coming on the ground. So that electric discharge between clouds, that is not dangerous to us. Yeah, the electric discharge between the clouds is not dangerous to us. It will not cause any harm to us. The only thing which we are concerned with is the electric discharge between cloud and the ground. Because when this electric discharge takes place, the lightning will come into the ground. So it will now cause damage to life and property. So this is the basic thing, that how it is dangerous lightning process. I think lightning process is clear. Thumbs up, guys. Okay. Now what we are going to see is the safety precautions during lightning. Safety precautions during lightning. Okay. So what precautions we have to take? First of all, this is a natural phenomenon. So whenever you observe or hear any thunderstorm, whenever you observe or hear any thunderstorm, quickly try to reach at a safe place, preferably at your homes. Yeah, preferably at your homes. But if you are on a road or traveling, then what you can do, you can sit or you can remain in your car or bus, whatever you are traveling in. You can remain in that with your windows and doors closed. Okay, still take a still position. Okay, so what is the thing you are take to you can take as a precaution is that those that seek shelter in buildings or cars. Yeah, always try to reach at a building or a car. If you are at a car, remain inside that car with doors and windows closed. Avoid isolated trees. Yeah, avoid. If you are in an open field, if you are in open field during lightning, do not I can say do not stand near a larger tree. Do not stand near a larger tree. Prefer to stand near a small tree. That is the saying. If you are in open field, if you are not in open field, you can remain at car or you can try to reach any building. Yeah. And if you are traveling in any bicycle, horses or motorcycle, get off them quickly. Get off them quickly, because why? Motorcycle, bicycles and horses are good conductor of electricity. Yeah, they are good conductor. And you know, in lightning, what is taking place? Sparks are coming, electricity is coming. So if the electricity is watching, or in the way of electricity, any bicycle or conductor comes, it will easily flow through it. Yes. And we also know human body is a good conductor. Human body is a good conductor. You can see in the second picture, this lightning directly strikes the human body. Yeah, this lightning directly strikes the human body, and human body is a good conductor. So what happens? Lightning coming into the human body, through the human body, it will pass on to the ground. So the circuit is completed, or the path of the current is completed. So you will die, or you will get very much harm or burn. Yeah. So in that case, you cannot save yourself. So what you can do to avoid the damage is that seek shelter in building or cars, avoid standing near isolated or bigger trees, get off the bicycle, motorcycles or horses. And if you are in a car or bus, try to remain in that with the windows and doors closed. So that is the thing. What we have done to, these are the don't which we are not required to do, that do not sit or lie down. Do not sit or lie down on the ground like this person is doing. Yeah. Do not sit or lie down. Otherwise, you will directly get in contact with the lightning. Okay. Second thing, do not return to open areas. Yeah. Do not return to open areas during lightning. At least wait for 30 minutes after the thunder has been stopped. Yeah. After the thunder has been stopped, wait for 30 minutes. Then only try to move on to open area. Yeah. Otherwise not. So whenever you hear any thunderstorm, as soon as you hear any first thunderstorm, try to go or try to take a shelter. And after the thunderstorm, wait for at least 30 minutes. Wait for at least 30 minutes after the last thunderstorm you have heard. Then return to open areas. Okay. Do not pitch tent near trees. Do not pitch tent near trees, because trees can fall. Yeah. Trees can fall due to lightning, and this will be dangerous to you. So these are the don'ts. So these are the things which we can do to avoid the damage during lightning when we are outside the house. When we are outside the house. So if you are inside the house, then what you have to do? If you are inside the house, then what you can do? Do not try to touch any electrical appliance. Yeah. First of all, do not try to touch any electrical appliances. Why? Because electrical appliances are good conductor of electricity. So if in any case lightning falls on your house, that will instantly flow through the electric gadgets or conductors which are present in your house. So this will cause a harm to you. So do not touch electrical appliances. First thing. Do not bath during lightning. Do not bath during lightning. Why I'm saying this? Because in the previous lecture, in the previous chapter of your class 8, that is chemical effect of current, you have seen that tap water is a good conductor of electricity. Yeah. So if you are bathing, what will happen? Water is a good conductor. Lightning falls on your house. It will travel into the tap. From that tap, it will travel into the water from which you are bathing. So from that water, lightning will come into your body, and you know human body is a good conductor of electricity. Yeah. So what will happen? Ultimately, you will get that. That's why it is recommended to not take a bath during lightning, and don't touch any electrical appliances during lightning. That is the thing. Okay. And one thing is also there, if you are standing on an open ground, do not stand or sit. Yeah. Do not stand, sit or lie down. What you can do, if you are not having an option to go or take a shelter, what you can do, you can take a squat position. You can take a squat position just by sitting, folding your hands and lying your head down towards your hand. So what it will do, it will reduce your surface area. So there are less chances of lightning falling on your body. Yeah. There are less chances of lightning falling on your body. So these are the basic safety precautions what we can do. So there is another safety precaution which is known as lightning conductors. There are one safety precautions which are known as lightning conductor, which are installed on our buildings. During lightning process. So what is the basic advantage of using lightning conductor? There is some heavy rod or metal rod. There is a metal rod standing like this above the building. It is connected to all the walls of the building. Yeah. This metal rod is connected to all walls of the building, and through that walls, it is going into the ground with a metal grate. So what is the advantage of lightning rod? That whenever any lightning falls, in case of lightning, if lightning falls on your home, this metal rod or lightning rod will directly take the electricity. Yeah, because it is a good conductor of electricity. So it will directly take the electricity or lightning and directly move it through this line, move it through this wire and directly into the ground. And you know, ground is a infinite capacity. Ground has an infinite capacity to take electricity. So that lightning rod will save your house from any damage during lightning. So that is the advantage of this lightning rod, and that this setup or arrangement is known as lightning conductor. The setup or arrangement is known as lightning conductor. That's why in every high-rise building, you have seen a rod like this on the top. So this rod is nothing but a lightning conductor that will prevent the building during the lightning process. And one thing is also there, our buildings are made up of steel reinforcement. There are some electrical wires also. So these things also prevent us during lightning, because if during any lightning electricity comes into your house, these steel reinforcement and electrical wires fitted in the walls will take the electricity. Okay, so it is recommended, do not touch any electrical appliances, do not take a bath during lightning when you are at home, and do not talk to a phone. Do not talk with a wired phone. Do not talk with a wired phone. Okay, these things you can do inside the house. Don't talk with a wired phone. Don't take a bath. Don't take a bath. And what else? Do not touch any electrical appliance. Do not touch any electrical appliance. So these are the precautions which you can take during the process of lightning. So that's how you can reduce. Although we cannot say the damage is suddenly brought down to zero, but yeah, it can be reduced by taking these kinds of precautions during the phenomenon of lightning. So I think lightning is pretty much clear to you. Yeah, thumbs up. Okay, enjoying. Okay, so next one is the earthquake. Next natural phenomena which we are interested to study is the earthquake. So what is basically earthquake? Nothing to explain. You already all are aware about the earthquake basically. So what we are interested in the science of earthquake, that how does earthquake occurs basically. Yeah, and you know earthquake is a very hazardous phenomena. It causes lots of damage to life and property once it occurred. Yeah, so that's why it is a very hazardous natural phenomena, earthquake, because you can somewhat predict the cyclone. Weather department can somehow predict the cyclone, that the weather is going bad, so there is a possibility of coming of cyclone, or you can say there is a possibility of coming of thunderstorm. So after thunderstorm, lightning will occur also. So that you can predict. But in the case of earthquake, you cannot predict when will the earthquake occur. Yeah, you cannot predict when earthquake will come. There is no phenomenon to predict that earthquake is coming at this point of time. So that's why that makes it a more hazardous process. That's why it makes it a more hazardous phenomenon. Okay, so what is earthquake? Earthquake is basically shaking of ground. Yeah, there is something shaking of ground related with the earthquake. Whenever ground shakes, the buildings or every object on the ground falls. Yeah, or building collapses. So due to that collapse and due to that breaking of the ground, there is lots of damage. Yeah, there is lots of damage to the house or property or the humans. Yes or no? So you can see the definition first. Earthquake is any sudden shaking of the ground. Sudden shaking of the ground caused by the passage of seismic waves through Earth's rocks. Seismic waves. Mark this point. Seismic waves. So it is the sudden shaking of ground caused by the passage of seismic waves through Earth rocks. Seismic waves are produced when some form of energy stored in Earth's crust is suddenly released. Usually when masses of rocks straining against each other suddenly fracture and slip. So what is basically written, that earthquake is any sudden shaking of the ground. Sudden shaking for a short interval of time. So what is the reason for that sudden shaking? That is the reason of seismic waves. There are some waves coming from the ground rocks, or I can say earth rocks inside the earth crust. Yeah. So these have some energy. When that energy is suddenly released to the ground, when that sudden energy in the form of waves is released to the ground, then that energy is reflecting as a shaking of the ground. Okay, and that is known as earthquake. So what is the basic science involved? If you can see in this left picture, sorry, this is a kind of shaking. Yeah, you can see the waves. So these waves are getting transferred into the ground. These waves are getting transferred into the ground, and the ground gets shaken. So that's why earthquake has come. And you can see on the right picture also. See, during earthquake, what happens? The roads, buildings, all things collapses, and humans are just kind of bury. Yeah, humans just kind of bury inside these structures. That's why there is some more amount of loss of house as well as property. Yeah, house, property as well as humans. I can say human life has also caused a lot of damage. There is lots of damage caused to human life also during earthquake. So what is the basic process of earthquake? There is something known as earth crust. Yeah, if you can see, this is a outermost layer inside the earth. This is the earth's crust. Earth's crust. So earth crust is consisting of several fragmented sections. Inside the earth crust, there are some fragmented rocks that are also known as tectonic plates. Tectonic plates. So there are some tectonic plates which are the combination of fragmented rocks, which I can say like this. Suppose this is one tectonic, this is another tectonic, this is another tectonic. So they are not as a combined rock. They are actually mixture of different type of rocks, which are combination of different parts of rock. So what happens? These are the tectonic plates. So every second there is some disturbance or straining or rubbing of the rocks taking place each other. Or I can say there is constant rubbing against the tectonic plates, every second. So what happens? I can say most of these times this shaking is not observed on the ground. So most of the times the shaking is so small, or the rubbing between the tectonic plates is so small that some energy is released, but this energy is not transferred to the ground. But sometimes approximately 1 in 1,000 times, what happens? These tectonic plates shake against each other, and due to that shaking, some energy is produced. What can I give example? Suppose you are rubbing your palm. When you rub your palm, you feel warm. So that is the energy produced due to rubbing. And if you can see inside the earth, there are large or huge mass of tectonic plates or huge size of tectonic plates. So if these big tectonic plates rub against each other, they will produce a very much high amount of energy. So if that energy is so high that it transferred to the ground from the crust, suppose this is the crust, there shaking is taking place, and suppose this energy travels to the ground. So this energy which is traveling to the ground will produce a shaking of the ground, and these waves or this energy which is traveling in the form of waves is known as seismic waves. That's why it is known as seismic waves. So seismic waves are the waves carrying energy which is produced by the shaking or rubbing of tectonic plates, and it is getting transferred to the ground. So this is the main reason for the earthquake. Other reason can be like this: whenever suppose any nuclear process is taking place inside the ground by artificial means, any nuclear process take place, it will also produce a lot of energy, and if this energy come to the ground, it will shake the ground. Another thing is the falling of meteor. Yeah, if any meteor falls on the earth surface, it will produce a shaking in that area. Okay, so that is the main causes of earthquake. But yeah, most of the time earthquake occurs due to the shaking of tectonic plates or due to the rubbing of tectonic plates. Okay, so these are the type of rubbing. You can see these are the tectonic plates. Whenever any rubbing takes place, this type of energy is released. Yeah, when energy reaches the ground, it will shake the ground. Also during any volcano eruption, it can occur. During any volcano eruption, shaking can also occur. Okay, and if you can see, if this shaking of the layer, or if this shaking of tectonic plates reaches the ocean bed, suppose this is ocean, this is ocean, so this is full of water. When this energy or seismic wave reaches the ocean bed, then this will produce a shaking of the ocean bed, and due to that shaking, that energy is transferred to the water, which is reflected as a tsunami or flood. So whenever earthquake occurs on an ocean bed, or produces on an ocean bed, it will give its energy to the tsunami, or it will give its energy to the waves. So that will produce tsunami or flood. So most of the time, tsunami and flood occurs due to earthquake only. Whenever earthquake occurs on the ocean bed, then that will produce tsunami. Okay. So where is the most likely danger of earthquake, or I can say the most probability of earthquake to be occur? So it is directly below the tectonic plate. Suppose this is the one tectonic plate, this is another tectonic plate. So this is the line along which they both will rub each other. Yes or no? This is the line along which they both will rub each other like this. This is the line actually. This is the line. If you can see, this is the line along which they will rub each other. This is the line. So this line is the most dangerous zone, which is known as fault zone or seismic zone. So So what is the thing that suppose this fault zone or seismic zone is present here. If I make it like this, these are the protected. Suppose this is the fault zone or seismic zone. So the earth surface directly above this zone, the earth, whichever portion of earth is present, whichever city is present, I can say whichever place or city is present just above the fault zone, that is most vulnerable to the earthquake. Why? Because shaking takes place directly here, so maximum energy is transferred from that fault zone into the ground. So whatever city or place is present exactly above the fault zone or seismic zone is most vulnerable to earthquake. Okay, this thing is clear. Now there is something which is known as Richter scale. Yeah, there is something which is known as Richter scale. So Richter scale is used to measure the intensity of earthquake. Richter scale is used to measure the intensity of earthquake. It is a scale basically starts, so yeah, it is gives us a reading as 4.5, 4.75. So it gives you basically intensity of earthquake with the help of graphs. There are something known as seismograph with the help of graphs. So Richter scale is a scale which gives the intensity or which measures the intensity of earthquake with the help of graphs. Okay, so this is the Richter scale. Now again, we cannot bring down the loss during earthquake to zero. But yeah, what we can do, we can take some necessary precautions during earthquake so that the loss of life and property can be reduced to some extent. Okay, so we are seeing some precautions that are required basically. So what are the precautions? Suppose you are outside the house. Suppose you are outside the house. You are outside the house. What you can do? Yeah, you are outside the house. What you can do? You can remain in car. If you are traveling in a car, you can remain in car with the doors and windows closed. Or if you are in open field, do not stand near to large trees, because if they fall, or you can also do not stand near tall buildings or any building, because what will happen during earthquake, buildings or trees will fall. So it is more dangerous for you to stand near those buildings or trees because they can fall during earthquake. Also, you should remain in car or any bus or any vehicle you are traveling in, closed vehicle. But yeah, doors and windows should be closed. Okay, clear? Yeah, so do not stand near buildings or large trees and remain in the car. That is the thing, that when you are outside the house, you can do these things. But what will happen when you are inside the house? Do not sit in the house near any object, heavy object. Yeah, do not sit any near heavy object, because that will fall on you, which will cause a harm to your life also during earthquake. Yeah, if you are on bed, you have to remain on bed. Do not move from here. If you are on bed lying down, then what you can do, you can take a pillow just to save your head. You can take a pillow and hide your head below that, so that you can get saved during earthquake. So these are the basic precautions which you can take. Yeah, these are the basic precautions. But yeah, don't get panic. The most important thing is that don't get panic. Don't get panic. And the best thing to do during earthquake is that always try to move away from structures or buildings. Always try to go on an open field. Which is far away from the trees or the buildings. So see, during the case of lightning, you have to stay away from the open field. But in the case of earthquake, you have to go into the open field to save your life. So these are the basic precautions we can see. And you can also refer to this diagram. If you are inside the house, you can take or you can hide yourself inside the table like this. So this is the exact position. Okay, during the earthquake. Yeah, you can do like this also. You can hide yourself like this also. You can also use a walker, and hide yourself inside this walker. Yes, and you can also use a wheelchair. If you are on a wheelchair, you can hide yourself like this. So these are the positions shown. You have to take to protect yourself during earthquake. But the main thing or major thing is that try to move on to the open field. Okay, and do not stand near the trees or tall structures. So I think the basic phenomenon of lightning and earthquake is pretty much clear. Okay, thumbs up guys. I think we have seen how they are occurred, how these two processes are occurred, and what precautions you have to take so that the loss of life and property can be reduced to some extent. Okay, clear guys? Okay, now see, we are given some question, that power of an earthquake is expressed on a scale. So we have already seen power or the intensity of an earthquake is expressed on a scale which is called as a Richter scale. So the answer will be Richter scale. Clear? What is next? Which is not a natural phenomena? Earthquake. Yeah, earthquake is a natural phenomena. Cyclone. Yes. Lightning. We have already seen it is a natural phenomena. Earthing. No. Earthing is not a natural phenomena. It is a process in which electric charges flow from the body to the earth. Yeah. We make our earth grounded. We make our houses grounded by attaching all the wires or all the appliances of the house with a metal plate, and that metal plate is buried inside the ground. That is the process which is earthing. So earthing is not a natural phenomenon. It is a process in which the charges from the bodies flow into the ground. That is that earthing. Okay. So I hope this is clear. So what we have read today in lecture, we have seen Coulomb's law, which is giving you the magnitude of electrostatic force, that F equals to K Q1 Q2 by R square. Second, we have seen electric field, that electric field is force per unit charge, or you can say it is an invisible region around any charge, in which if you bring any other charge, it will experience an electrostatic force. Yes. Then we have seen what is lightning. Lightning is due to a process which is known as electric discharge. If electric discharge is taking place between the clouds, it is not causing any harm to us. If the electric discharge is taking place between the cloud and the ground, then that is harmful for us. Then we have seen some precautionary measures during lightning. Yeah. And we have seen some technology which is known as lightning conductor, which is installed in every building to save our buildings or us from the lightning phenomena. Then we have seen what is the earthquake. Earthquake is a shaking of the ground for a short interval of time. Why it is produced? It is produced due to the rubbing of the tectonic plates. So some energy is released during that rubbing, and if that energy is transferred to the ground, it will reflect as a earthquake. Okay. And there is a scale to measure the intensity of earthquake, which is given by Richter scale. What is the most vulnerable region for earthquake? It is known as fault zone or seismic zone. Whichever city or place is directly above the fault zone or seismic zone, which is the intersection line of the tectonic plates, so that city or place will be most vulnerable to earthquake. Then we have seen some precautions to take during earthquakes. So the major precaution is that always try to move on an open field. Always try to move on an open field which is away from the large trees or large buildings. Okay. So I think today's lecture is clear. Yeah, I think this chapter is completely clear. We have covered every topic of this chapter with a full flow. Yeah, guys, thumbs up. So that is the end of this chapter. Yeah. So if in any case you find any doubt still now, then you can refer on to the doubt forum. Yeah, you can post your doubts on the doubt forum, which is present on askIITians website, and you can get your doubts resolved by expert faculties. Okay. So thank you guys. Stay safe and enjoy. We are ending this lecture. Thank you. Bye-bye, guys.